Hello, my name is Marcus Merrell, and I'd like to talk today about testing and accessibility using Sauce Labs and Sumo Logic. I'm the Vice President of Technology Strategy at Sauce Labs, and what that title means is kind of a strange title. What it means is that I try to assess the whole platform and the strategy of Sauce Labs and figure out where the gaps are in the platform. Every platform has a gap, right? So I try to fill in the gaps in that platform with either building a product or acquiring other companies or with partnering with companies very much like Sumo Logic. And they help us fill in the gaps in our portfolio to make sure that we offer our customers the best we possibly can. This comes after an 18-year career in quality assurance, test automation, API testing, and being part of a very deep part of the Selenium community. And I decided I wanted to figure out how to apply my skills at a vendor because after years of teaching single companies how to do these things over and over again, I thought I need to go and teach hundreds of customers, people how to do this, and hopefully expand the product and do a whole lot of good for the world while I'm at it. Now, along the way, I picked up quite a bit of a passion for the topic of accessibility, and that's what I wanted to talk about here today. So let's get into the intro. What we're going to try to talk about first is, normally I do my talks in front of a testing audience, but I realize that may not be the case today. You're at the Sumo Illuminate conference. You're probably here as a developer, and you might be here for a tester. You might be here as a developer. You might be here in SRE, DevOps, whatever background you come from. I think it's important to level set on why we want to talk about testing in the first place. I feel like everyone knows about testing, and everyone knows kind of vaguely why testing is important, but it's also seen as kind of a cost center, kind of a chore, kind of something you have to do at the end of a release just to make sure that you've checked all the boxes. And I want to try to sell you on the idea that it's a lot more than that. It can even be fun. After that, I want to talk about real risk as well as how to scale this testing to make sure that you have the right idea going into it about how you can evaluate and measure the results and make what I guess you'd consider a guarantee to your management that when something is tested and something is green, the build is good, that you have done everything you can to make sure that you've mitigated the risks and you've identified the issues that might go out there. And finally, you can feel free to send me questions, anything that comes up here in the Sumo community, as well as I'm on Twitter at MMERRELL, at mmerrill. I don't really do a whole lot of Twittering, but I certainly see the ats when they come my way, and I'd love to follow new people, and I'd love to start a conversation there, especially if it's something in public that other people can learn from as well. So let's talk about why we test. People believe, I think, commonly that we're looking for bugs. We're trying to find where it's broken. The PM, the project manager, told us that something should work this way, and the developers agreed, so they coded it up that same way, and we need to ensure that everything works, right? Like you say, they said the thing should be blue when I clicked it, but it wasn't blue. And you submit a bug like that, and that's typically the way we see bug reports, is that this thing was supposed to work this way, but it didn't. And if you're really lucky, someone will say, it didn't work, here's how it should have worked, here's what happened instead, here's very specific instructions, here was the stack trace in the report if it was an error, here's, like, the more detail you can get, the better. But what I'm trying to sell is that it's not exactly that you need to be describing the bugs. You don't need to be just finding the issues as the product manager and as the developer said. What we want to do instead is think of testing in terms of risk mitigation, risk identification from the user point of view, from the user experience point of view. You don't want to just know that something didn't turn blue or did turn blue. You want to say, why can't I submit this form? I'm supposed to be able to submit this form, and here's the reason why I think it should be really important for the user, that kind of thing. You need to argue that the emotional experience of the user when they're using your software is very, very, very important. I think we all have that frustration and rage when something doesn't work well. Do we have a similar dopamine shot of pleasure when something does work well? Pretty much we do during video games, but sometimes I work on a website that's so delightful to use, it's a genuine pleasure. And that is a fairly rare experience. And I really want people to try to go for that instead of just looking for what's broken. I want to start moving from the concept of a minimum viable product to a minimum lovable product. MLP. Let's start that as a new acronym. Now, how does this apply to accessibility? we need to start thinking about a whole other kind of level of empathy when we're talking about accessibility and we're talking about using the web. They said the thing should be blue when I clicked on the other thing, but the real problem is that there isn't enough contrast between this blue and the background. This button blends too much into the background, or worse yet, maybe the text is a light blue and the button is a dark blue, and you're not seeing the difference between the two. So someone with visual impairments might have a lot of trouble understanding what this button is trying to get them to do. Once we accept that testing is about risk and that testing is an important facet of how we need to release our software and how we need to delight our users, then we look at how to scale the testing. Because as Drew Horn said, this is no longer a human scale problem of testing. Once we try to get a handle on all the features that we've released and test for all of the different issues that might come up and all the risks that might happen if we have an escape to production, what happens traditionally is that there's this huge bottleneck of testing that occurs somewhat close to the end of a release. So you are done with the product manager making requirements, you're done now with the developer coding up the features, and now everyone sort of sits around and waits for the testers to finish up their testing. And what that led to was this big blob of activity in the middle where you're sort of planning the next iteration, but mostly you're waiting for the testers. This feels like what was happening in the testing industry around 2000 to 2010, before we all started to try to get on automation, maybe even up through 2013, 2014, before we really started on this concept of shifting left. Now, what happened when we were shifting left is that we decided we're going to get developers involved in this. So we're going to take up a whole lot of time at the beginning of an iteration, getting the developers to work with us on test cases. It's going to cause this whole range of activity while other people are probably sitting around waiting for us to finish defining the tests. And so it created another bottleneck. It moved the bottleneck to the left. And it also probably got a little bit more expensive because there are more developers and they tend to cost more to your bottom line when they're spending a lot of time on this. And then there was this kind of a move towards shift right, which hasn't always even taken place in a lot of companies. And these eventually just end up becoming noise. These are buzzwords. These are things that really don't hold any meaning for people. When we say we're shifting left, we're shifting right, it's all just moving the bottleneck around. When what we're actually trying to do is continuously weave testing throughout the journey of a product feature so that you barely notice that it's happening. You write several lines of code, you write a unit test. You write several more lines of code, you write a unit test. You create a build, you create a new API endpoint, you create an integration test. When you code up the new front-end features, there's a Cypress test. When you string all of it together from the front end to the back end, you create a Selenium test. Then you distribute this to your users so that they can test it themselves and report the bugs back to you. And then when you put it in production, you watch closely for error monitoring and things like that. And then you tie all of this back to Sumo logic and the observability platform so that you can make sure that not only are your users having a decent time moving through your software, but also the testing process itself is being tracked and delivering the metrics that you want it to deliver for observability's sake. So that's how we scale testing, because it's simply no longer a human scale problem. We can't just hire more testers, more bodies, more people to sit and do this kind of testing, because you can't be confident in shipping when that happens. Testing can be easy. Testing well is always hard. Even if you're good at automation, understanding where to apply this skill and where to understand the risks to your business is very, very difficult, and it doesn't really get easier as we go along, especially as software gets more complex and user expectations grow and grow. There are some statistics that talk about how quickly people will abandon your brand after a single bad experience. Those are available in the Every Experience Matters report that I'll be submitting as a link along with this presentation. But what we need to understand is that the world is changing and it's becoming more complex and people are more impatient than ever. So when we get to the point of testing for regressions, we understand, because we've done this before, that testing for regression is very tedious. It's something that we really ideally would like the computer to do, because after the 15th time you run a single test, it simply, your eyes glaze over and you've been looking at the same thing for so long, it's hard to be objective. It's hard to maintain the energy level you need in order to really find the bugs you need to find and then emulate the user experience that you're seeking to emulate. And the other thing you got to worry about is that if you're making a web application, there's Chrome and Edge and Firefox and Safari, and those things get updates every couple of weeks. And operating systems, Windows and Mac OS, they get iterations every couple of months. And there are security patches, and there are libraries, and there are other things to consider when you're trying to figure out what your users want and what kinds of user setups you have going in order to be able to make sure that you're covering everything. And that's not to mention things like iPhones and Android devices and everything that iterates from the hardware and the software level, as well as the different libraries that go into those things. And maybe there are security vulnerabilities. So it's not just your software. In fact, if you look at all of the code that's being iterated on, every time a user uses a piece of software, probably 10% of it is something that you or your team wrote. 90% of it is going to be something that someone else wrote, maybe years ago, maybe something in a mainframe, maybe something in a database. And this is where an observability platform like Sumo becomes extremely important, is to be able to look at all the different signals that are being thrown off by the system as they're moving through all these different kinds of code paths that nobody in your company wrote, and to be able to try to understand what happened and draw conclusions to be able to identify risks. This creates this combinatorial explosion, meaning that you have two different browser versions. That means there's two different browsers to work on. Well, then if you have Chrome versus Firefox, and each of those has two different versions, that's 4. It becomes multiplicative. And then when you add Safari, that's 6 combinations, but it's also much different in terms of how you do the math for the different parameters that you're trying to cover. At some point, it's very easy to believe that if you have 30 different things you're trying to test for within your own application, you might actually have hundreds of thousands of test cases you need to be able to cover in order to make sure that you're getting through all the platforms and operating systems that you need to in order to give yourself confidence that you've tested everything. Now, there's a lot of ways to make this simpler, which we won't be able to get into today, but I'd love to have the conversation on Twitter. Combinatorial, set reduction, all sorts of kinds of things to be able to give you confidence that you're covering the topics that you need to cover. Automation can combine multiple steps into a single step, and then not miss any of them on repeat. When you're a human and you're trying to look at the same thing over and over and over again and your eyes glaze over, wouldn't it be nice if you had a robot help you miss the things that you shouldn't miss? Maybe some of the text in the bottom of the screen has a low contrast to the background, but you missed it because you were looking at the rest of the screen, and the one thing that you think might be wrong with it based on the changes that have happened in the platform recently. And there again, you can have a computer iterate over the millions and millions of different combinations of things that might go wrong or might create a difference within the system, a difference in state as you're moving through these spreadsheets. You want a robot to help you with that. And for accessibility, of course, what you need to understand is that accessibility is not only about the software that you're creating, it's also about how that software interacts with the operating system underneath, which has screen readers and other kinds of technology that can assist, as well as the fact that you probably haven't been trained in accessibility, and unless you have an impairment yourself that might create issues with screen reading or with hearing, that you need to understand how to have empathy for those users who have similar kinds of issues. And then you need to be able to test for these things and make sure that they don't regress after a change to that software. Small changes that happen in one area of the software can have profound impacts on the area that you might be looking at. And it might have something to do with cascading style sheets written by a front-end engineer who lives in a different continent than the one that you live in. But that might create a text contrast or a screen reading or an identifier issue on a web element that you are looking at. So these kinds of things can have effects that you might not be able to keep up with every single day. So it really helps to have a set of scripts and a robot helping you iterate and look at these things every single day. What we found in our Every Experience Matters report, and the link is here below, and we can ship this out separately, is that 15% of all web users require assistive technology in order to get their basic tasks done in a given day or with a given workflow in a piece of software. And over 60% of those people on a daily basis are prevented from doing these things every day. So what I want you to think about is the opportunity in front of you if you do manage to make your software accessible. Now, first of all, it's the right thing to do, and you should absolutely do it. But if that isn't enough somehow to be able to sell your company on making your software accessible, I want you to imagine that you could wave a magic wand and increase your audience size by 15%. Now, I'm not saying that that will happen if you adopt accessibility, but I'm saying that the 15% of users that you could be addressing are only going to be addressable by you and the competitors who have also made your site accessible. So if your software is accessible and none of your competitors' software is, then you have the potential to capture the 15% of the market that needs assistive technology. If you're, there's one other competitor that is accessible and you're not, they are getting access to that 15%. This is whole number percentage points that you could be getting access to as an audience that I think there's no debate, having worked in e-commerce myself, that a whole number percentage point of conversion or lift or access to an audience is big numbers for just about any company, and it will make your CEO's ears perk up when you talk about it. So that's one thing. And then the other piece to really understand is that if that isn't good enough to convince people to go for accessibility, keep in mind that there have been major lawsuits that have been won by people who have sued major companies over the accessibility of their site. There was a very famous pizza chain who in 2019 lost a court case that went all the way up to the Supreme Court, and they had lost in appeals, and the Supreme Court refused to hear the case that said that having access to a mobile shopping cart or a shopping cart on a web page is exactly the same as a brick and mortar store having a wheelchair ramp. And that if you don't provide a reliable way to order pizza or order food or anything that is accessible online, then your site is violating the Americans with Disabilities Act, and that you could be sued. And this has happened now several times. And what we are starting to see is a proliferation of accessibility trolls that are actually going after companies whose sites are not accessible. This is similar to the patent trolls thing that have been happening for 20, 25 years in the software industry. Now it's starting to be applied to accessibility. Those are three reasons in escalating order. And I hope for your sake, and I hope for everyone's sake, that you can just say it's the right thing to do, and that's a good enough reason. Let's hope. So it's interesting that 95% of accessibility problems come down to 12 different issues. And I'm not going to go through the list. It's just we don't have enough time, but it's basically contrast issues and identifier issues for screen readers and things like that for basic stuff. And these things can't, one thing I should say, that we can never cut the human out of the accessibility equation in testing. What we're trying to do is reduce it. We're trying to cut out the most toil-laden, the ones that really make you go a little bit crazy when you're trying to test them, and to make sure that you can try to get the robot to assist you in finding the most important ones so that you can concentrate on the ones that are a little bit more subtle and a little bit easier to find. We estimate that 50%, I believe the latest number is 57% of accessibility issues can be found via automation. Now, with a combination of Sumo Logic, Sauce Labs, and DQ, the three companies that we're talking about in this presentation, you can find probably about 85% of issues that would be between the manual testing offering that DQ offers, as well as the automation that Sauce Labs and DQ offer together, as well as reporting these back to a centralized dashboard, centralized observability platform like Sumo, and be able to report these kinds of issues to your management in real time to be able to make decisions driven by data that will affect your business the most and the quickest. So let's talk about the consequence of what happens when bugs escape into production. Now, this is kind of an old chart, and in fact, I believe it to be a little bit conservative, but it talks about when a bug is introduced compared to when it's caught, and how much it costs you in terms of real-world dollars in order to fix the issue based on that. So imagine you have a small arithmetic error that's on some sort of accounting program. You're trying to apply an interest rate. You're truncating at a certain number of decimal places, and you want to make sure that the math computation is done right. If you don't write a unit test for that, and you do actually let this bug go through, and it's truncating to 4 digits instead of 6, so the precision on the interest rate calculation isn't quite as good as maybe management thought it would be. Management probably thought you had that requirement and that you made it 6 digits. You actually made it 4 digits, which means it's rounding up in the wrong place that you didn't expect. If that thing is caught in a unit test, it's going to be fixed by the end of the afternoon, and chances are good that only you would ever have to know that it happened. Now, if it goes all the way to integration testing, it's likely that it happened during a CI/CD build and something was caught. There's a math problem that it allocated something after a few calculations, and it was off by a few pennies, and your integration test caught it, and so it has to go through another round of changes, another round of unit test updating, a round of integration test update, and then another round of CI/CD. So we're talking, tens to potentially hundreds of dollars. Now, if it gets out to system testing and you wait until a person who's actually running a scenario on their while they're testing the website, when they catch it, that issue is now going through potentially dozens of people and lots of times and lots of different kinds of testing in order to be able to update that scenario, that piece of code, so that it can be done in time. But if it makes it into production and it's costing your customers real dollars in terms of, or your company real dollars in terms of either paying too much or collecting too little interest, that's going to start mattering to the bottom line. And if it goes any further than that, we're talking about exponential amounts of cost, because suddenly you find out that it's been out in production for a while, and it might be something that would even cause a vulnerability that people can exploit, and it might end you up on page 2 of the Wall Street Journal, which is probably everyone's worst fear as a security professional or as a software development person. So the cost of bugs can go up exponentially as time goes by before they are caught. Applying this to accessibility, that's what gets you sued in such a way that it goes up through multiple federal appeals courts, and then finally the Supreme Court looks at it and says, no, we're not going to even look at that. Of course it's correct. That's the right ruling. That kind of an issue could have been caught much earlier, but here we are in production, and someone can't get their pizza. Suddenly you might as well have demolished the wheelchair ramp on your brick and mortar store. It's the same thing. There are different standards for accessibility testing. People with some abilities will find it impossible to access the software. Is a single A standard for accessibility. Most companies will start with single A, then they'll iterate to double A, then they'll iterate to triple A. These are different kinds of standards. They have very many different details to them, and I will not try to recount them here because we don't have time, but they're all made up by a group called the WCAG standards. And that's a group that's it's a standards body that's the same as the W3C, the World Wide Web Consortium. They work together with that group. It's a group founded by Tim Berners-Lee 40 years ago around the standards for the web in general. And these standards are constantly being iterated upon and studied so that they can be fixed, so that we can serve our users in a more complete way and not exclude people because they need certain simple assistive technology in order to get their processes done. Let's talk a little bit about how to do it. Now, once again, I don't have time to go into exactly how to do these things today. Like I said, please contact me on Twitter, and we have some documentation on saucelabs.com as well that will help you understand not only the importance of accessibility, but how to get started on it, both web and mobile. The main thing we need to understand is that beginning and non-testers don't tend to look outside the happy path. When you first get started with testing, you want to essentially make sure that the thing you understand about the software is true. The assumptions that you make around how the software works do actually work the way you think they do. You don't tend to look for what we call edge cases or boundary conditions to make sure that, if you send an error message or you send gibberish or you send non-printable characters, you tend to do that as you become more and more advanced. And then, interestingly, you actually start to do so much of that you over-index on it and then forget about the happy path and forget that fundamentally your job is to try to understand the user experience and make users happy. But what we need to do for accessibility is make sure that we are encountering the everyday scenarios that people go through. Now, it's interesting, DQ that I mentioned, DEQUE.com, they actually have something they call an empathy lab that allows you to be able to use software in a way that generates empathy for people with visual impairments. It makes you use software that is inaccessible to people with a blindfold on or something like that, where it would make it to where you have to be in the shoes of someone who it requires assistive technology in order to be able to use your software, and then they put you in front of this software where they know it doesn't work to try to help you build empathy for these folks. And this will help you do things like make sure you have identifiers on all of your text boxes, because if you don't have identifiers and a screen reader is looking at a form, all they see is, or all they will hear is text field, text field, text field, text field, when what they should be hearing is first name, middle name, last name, address, city, state, zip code. They will have no idea how to fill out that form if you don't make it accessible with identifiers to let people know how the form works on a fundamental level. Another thing to point out is that Apple, Google, other operating system makers create assistive technology called a screen reader, which works at the operating system level to help you hear what's going on a web page. And a lot of people are trying to figure out how to test the screen reader itself, when I would argue that the screen reader is being made by Apple, not by your company. Your company makes your software to make sure that it can be, it's instrumented to be able to be read by a screen reader, but Apple made the screen reader, and you don't probably need to be in the business of testing Apple's software. So by using tools like DQ and Sauce Labs, you can actually measure and scan your site for screen elements that do not have these sorts of identifiers, so that a screen reader would look at. The screen reader can't really help you that much when you're actually listening to it, compared to just scanning the IDs to make sure that they work right. The other thing about testing is around areas of responsibility, in that when you're testing for accessibility or functionality or anything, if your software is sort of a portal, or if it has links out to PayPal or Twitter or Facebook, you don't need to test their software. I've found this many times with testers, not even just beginner testers, but pretty much anyone who has been doing it for a long time. They feel like they need to test to make sure that these different APIs that send analytics or that link you directly to Facebook or Twitter, that they actually work all the way through. And the truth is, you probably shouldn't do that. You can mock out endpoints to make sure that your software understands how to interact with these sites, but you don't actually have to test the site yourself. And the same goes with accessibility. Facebook, if they are accessible in their widget, then it shouldn't matter to you whether or not they are accessible in their widget that you're embedding on your site. The truth is, if they're not accessible, you can't make them accessible, because they're embedding something in your site that you didn't create, you don't control. So you need to have confidence that as long as your site is instrumented for accessibility, that the third-party sites that you're interacting with, they need to take care of their own thing and take care of their own business. And if they don't, then you open a ticket with them directly. You call them on the phone, you do whatever you can in order to be able to make sure that they hear you, that someone can't, if someone's using this software and they're going through your software to theirs, that it puts you and them on the hook for any sort of liability if their widgets are not accessible. Once you've got a handle on your automation, then it's time to figure out how to integrate that with Sumo. And that's a really exciting opportunity for us, because traditionally Sauce Labs has lived inside the QA silo, and Sumo has lived inside of, the rest of everything else about development. And what we want to try to do is make sure that these different silos have been broken down. Now, everyone talks about that. We're doing this in a lot of different ways. Some companies are better at it than others. But this represents a real opportunity for a conversation to be started between the stakeholders in QA and the stakeholders in development and product and SRE and DevOps and everywhere else, where you need to be able to verify that everyone understands the risks of what's going on inside your software. Opening up the Sauce Labs infrastructure to monitoring through Sumo, which is something that we can accomplish by looking at documentation on Sumo's site as well as on Sauce Lab's site. There's an app that we can install. This gives you analytics about performance and the robustness of your automation suite. It's not just important enough for your automation suite to test whether or not your software works. It's very, very crucial to look at how well your automation is performing, because Selenium is notoriously a very chatty protocol, and sometimes it can be very, very slow when it's sending all these commands across the wire. And the more introspection you have about that, the more time you can save, the more redundant commands you can clean up, and all sorts of things you can correlate, prioritize, and surface around the big problems within your automation suite. Because the better your automation suite is, the more trust your developers will have in both your automation suite and yourself and you. If your builds are green consistently, and then one day they're red, suddenly everyone pays attention because they understand that your automation is trustworthy. It's not flaky. It's not inconsistent. It's not slow. And this is how the partnership between SOS and Sumo really should be able to be leveraged by anyone in the quality assurance sphere to understand how to get observability working on QA as well as dev and release. So this can lower your mean time to recovery. You can get feedback into the Sumo's observability platform. You can correlate testing with the data with the application itself. You can use analytics in Sumo, like the Sauce Labs app, to drive the conversation about the effectiveness of your tests. Here's what it looks like when it works right. You were able to send information about the tests straight through to Sumo Logic and make sure that the metrics are being gathered around test fails, test passes, test execution time, browser platform coverage, and mobile device coverage, iOS, Android, as well as different operating systems, the different kinds of formats you need. And these are things you can correlate with people in business analytics within your own company to find out, hey, it actually turns out that there are still people using something like Internet Explorer or Chrome version 72, and we're making money off of those, so we can't shut down support for those. So they need to show up in your QA report. You need to make sure that you're still covering them. Or Safari. Safari is a big case where traditionally people who are running something like a Selenium grid for scalability, they typically skip Safari because it would mean they have to purchase Mac Minis in order to be able to run Safari tests within their grid. And through a combination of Sauce Labs and Sumo, you can actually not only run on Safari easily without any extra effort, you can also make sure that that data is reported up through BA and that you don't have to open up the entire QA bag of tricks to let them know and do all this work to build a dashboard. It's all going to be built straight into Sumo. And here's another slide that explains how this can look at the end. You get your platform coverage, you get your browser coverage, you get your execution times, and there are so many more points of data that we could build into this around the Selenium performance or Cypress performance, Playwright, Puppeteer, Test Cafe, even API testing that we've got working now inside of Sauce Labs. And all of these things can be used with Sumo Logic, their observability platform, to make sure that you're getting the best you can out of your testing platform and that conversations and decisions are driven by the right data points for you to be able to make decisions at scale once you know that your testing is something you can have confidence in. Confidence is not something that just happens overnight. And in fact, a lot of people I know have never really been through the transformative confidence that it gives you when you nail your automation testing. So that's what I wanted to talk about today. And I want to make sure that everyone is, you can send me an email. My email address is at the bottom right of this page. You can send me a Twitter. Once again, it's at MMERRELL. And like I said, I want to help you nail your test automation so that you can make sure that you have confidence that every time you ship software, it's the right thing, because every experience matters.